Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this video, we are starting our very new module, which is about the unsupervised machine learning techniques that we want to explore here, right? So until so far, if you remember, we have explored about all the supervised machine learning techniques that we have learned so far. What is the meaning of that? So you will observe in our projects, whatever things we have explored so far, the target column is given to us, right? Whether we are talking about linear regression, logistic, SVM, KNN, whatever algorithms we have explored so far, in every particular algorithm, we have seen that somehow the target column is available, right? So, in that case, or that kind of technique, that kind of algorithm which works under that particular scenario is supervised. Now, in this case, where we are starting our journey with respect to the separate unsupervised algorithm, what will happen is the target column is missing. So we will have to study in that scenario where the target value, the label is not there. How can we able to achieve the results? And you will observe in practical real-time scenario, there are so many data points available where the label is not there, especially if you will observe in healthcare data labeling is not there. So what we want is our model will automatically able to understand the patterns. Our model will be able to automatically group the similar kind of a patterns, which we call as clustering in machine learning. So in this complete module, we will start discussing about uh, first of all, how many types of clustering techniques we have, what is the meaning of clustering, how internally model does the clustering. At the very first go, we will start our discussion in this video with respect to k-means clustering approach. We have so many clustering algorithms like k-means, hierarchical, dbScan, and at the end of this module, you will observe I am covering up one end-to-end project, which is with respect to customer segmentation. We will see that whatever knowledge we have gained so far with respect to unsupervised machine learning technique or approaches, how can we apply those learnings in our real-time industry level project, which is end-to-end pipeline, which I will try to showcase you. So without wasting any time further, let's get started. So now let's try to understand first of all what is the literal meaning of clustering. As we have seen, it's a technique which will come under the category of first of all unsupervised machine learning. I hope this is clear to everyone that what is the meaning of unsupervised machine learning. Wherever we are seeing that labeled data is not available, labeled data is not available. In that case, we will say it's a part of unsupervised machine learning, or in that way, we have to apply the clustering techniques. Now, there are multiple ways, but before focusing on what are the algorithms or the ways we have via which we can apply this clustering technique, we have to understand how internally these things will work. For example, I will give you a very simple, example to understand this fact that let's say I will be having a lot of data points with respect to the spending score of the different people that we have in Bangalore, let's say. Now, many people will be having a HDFC bank as their salaried account. I'm just giving you one simple example. Salaried account, right? In the HDFC bank, in specifically I am talking about Bangalore. Okay? Now let's assume कि I will be having a data points available with me. I have a lot of data sets available with me. And in the x-axis, I will be having a age of people. And in the y-axis, I will be having their, let's say, spending score. I will be having their spending score, right? That within a month, and I'm talking about in a month, okay? In a month, specifically, let's say how much they will be able to spend. Specifically, let's say we are focusing on groceries, outing, traveling, parties, whatever things you can think of in the weekends, wherever they are exploring the stuff. So, how much is their spending score on the basis of their spending history, transactions records, which is available in the HDFC bank as they have their salaried account in that specific bank. Now, this bank wants to understand, depending upon the spending score and the age of a customer, maybe the loan offers the bank wants to give to them. Maybe they want to give a higher interest rate to FDs. And there are so many credit cards going on in HDFC which they want to give depending upon how much is the spending score any customer will have. So what will happen? I hope you must have encountered, you usually get a calls from the banks by saying that, okay, you are approved to 10 lakh rupees loan or 50 lakh rupees loan, depending upon how much is your spending power you have, because bank do have a history of your transactions, right? That's why they're sponsoring these kind of offers to you. Now what will happen is, let's say I will be having few data points available here, where I will be having, I can see that people having a lower age. When I'm saying lower age, let's say I'm categorizing the age range as, let's say, 20. Okay, 22, it's very less. Let's say we will say maybe 21. I think after pursuing BTech, we do have a age of 21 if we're not drop out. So let's say from 21 to 25 is one range. From 26 to 31 is another range. From 32 to, let's say, 37 is another range. Let's say as of now, I'm focusing on three specific ranges that I have. Now, what I have observed is that the people who lies from 21 to 25 range will be having a low spending score, and as the age increases, the okay, there are few outliers as well in this data, but still as the age increases, people belongs to this kind of category. Then maybe they are belonging to, as their further age increases, maybe they will be having more responsibilities as well. So maybe we can say that they belongs to, let's say, some different category like this. Okay? So depending upon their now scores, their spending scores, let's say here this range lies somewhere here, 32 to 37. What I want is, I don't have a label data. Okay? I don't know that whether their spending score is very high, moderate, or low. What I want is, I want to apply clustering algorithm which will help me to figure it out, that wherever the similar patterns are there, automatically it will be able to cluster those patterns, group those patterns, and maybe they can say this is the C1, this is cluster number 2, and this is cluster number 3, or you can say this is the group number 1, group number 2, group number 3. And this is the kind of task which we will perform in this module as well, named as customer segmentation. Obviously dataset will be completely different, but you will observe that this is a very good example which I can showcase to as a practical example, with the help of which you will be able to understand what is the meaning of clustering. So clustering means that simply we are trying to group the similar data items depending upon their similarities internally, identifying the patterns, and accordingly we are trying to signify that, okay, these belongs to somehow one group, second cluster belongs to another group, third cluster belongs to third group, right? Depending upon the patterns that they are observing in a data set. Now we can achieve this kind of a outcome with the help of, majorly you will observe there are so many algorithms by the way, but we will in our course first of all discuss about k-means clustering algorithm, which is a quite famous algorithm, and we will try to discuss how this k-means clustering algorithm will be able to perform the above kind of task, right? What is the internal intuition behind that? How does it works, right? So k-means clustering algorithm says that, let's say you will be having few data points available with you. Maybe this is the one category of data points that you have, and this is the another category of data points that you have. And now you want to apply the clustering algorithm in this particular case. So k-means clustering says that first of all we will randomly choose the clusters. Now what does this k indicates? K indicates the number of clusters in this case. K indicates the number of clusters in this case. So what we say, ki we will randomly choose this value of k, although there is one of the very famous algorithm in k-means clustering which we called as elbow method. We will discuss in the upcoming session that how this elbow method is basically help us to choose a optimal value of k. Optimal value of k. What is the meaning of k? The number of clusters. K means number of clusters we are talking about here. But as of now, let's say we are randomly choosing any value, because we are, as of now, as a beginner, we are not focusing on the optimization part. We're just focusing on understanding the algorithm as of now in the very first video. So what we are saying is, let's say I will choose the value of k as 2. I will choose the value of k as 2. Now, what will happen is we will try to see let's say we randomly choose the two clusters here. Maybe I am saying this is my cluster number 1 and this is my cluster number 2. This is my cluster number 1, this is my cluster number 2. I have randomly chosen any of the two clusters. Now, what I will do is I will try to find out the distance of all the data points from cluster C1 as well as cluster C2. So what I'm saying is I will try to find out the distance of all the data points from cluster C1 and C2. Now let's say there are few data points which are very close to C1. There are data points which are very close to C2. And accordingly, I will try to filter the data points. Okay? So now when I'm saying distance, there are multiple ways to calculate the distance. Majorly speaking, we will discuss two ways. One is the Euclidean way. Another one is the Manhattan way. Now, in your mathematical sessions, I hope in your lower classes, you must have heard these two different ways to calculate the distance value. But in a nutshell, what is the meaning of Euclidean distance? For example, let's say you will be having a point P1 having a axis x1 and y1, and you will be having a point P2 having value x2 and y2. Euclidean distance says that the formula to calculate the distance between these 2 points from P1 to P2 is the difference between the value of y2 minus y1 square plus the difference between the value of x2 minus x1 square. So this is the first way with the help of which I will be able to calculate the distance between the 2 points. And this is what we called as Euclidean distance. Euclidean distance. So what I'm saying is, we are trying to find the Euclidean distance by trying to doing a square root and then finding the difference between the two values and doing the complete square of that. This is the first way. Second way could be the Manhattan distance. Manhattan distance. This says that let's say again you will be having 2 points. Again, let's say you will be having 2 points. Point P1 having value x1 comma y1. Obviously, as of now, we're dealing with the two x's only, x and y. So that's why I'm taking x1 and y1. And this is x2 and y2. So Manhattan says that we will take a difference, absolute difference between the value of y2 minus y1, absolute difference, plus the absolute difference between the value of x2 minus x1. So this is something which is the way to evaluate a Manhattan distance. Now, logically, if you will ask me, Priya, what is the difference between these two? Okay, you have shown me formula to evaluate both of them. But practically, if someone will ask me that where this difference basically lies between Euclidean and Manhattan, so let me give you simple mathematical idea. For example, let's say you are starting your journey and you are starting your journey from, let's say, here. This is your start point. And let's say you want to reach here. This is the destination that you want to cover up. Okay? You are traveling somewhere. I'm saying this is your start point. This is your destination point. Now I'm saying, can you give me the difference or the distance from the start to the destination? Can you tell me how much is the distance we have? So one way could be where you can evaluate the direct distance between the start and the end, right? This is something which is the way of Euclidean. This is the way of Euclidean. But if let's say you will say, Priya, what I will do is, first of all, I will try to evaluate the difference between these two. And then I will try to evaluate the difference between these two. And then I'll add, let's say the distance is A and B. So what I'll do is I'll try to add the value of the distance of A and B. So this will become your Manhattan distance mathematically, I would say. Okay? This will become your Manhattan distance mathematically. So there can be two ways as for now you can understand. One is the Euclidean way to evaluate the distance. Another one is Manhattan, which is focusing on the absolute value. Now, you can change the configuration in the parameters of k-means if you want, but by default it is Euclidean. Okay? So by default it is Euclidean, which is available. If you want to change, you can change to Manhattan as well. Now, what is happening is for every cluster value that you have, which is, let's say, this is C1 and this is C2, you are trying to evaluate the difference between all the data points that you have. Now, let's say C1 is there and there are near points which are nearer to C1, that will become your first cluster, and the points which are near to C2 will become your second cluster. Now, let's say you are saying that this is the first cluster which I will be able to get because the distance of the C1 value with respect to all these data points available is very, very close. And this is my C2 value where the distance is closer to C2, not to C1. Now, what will happen? You will try to again recalculate the value of C1 and C2. Now, what will happen? How will you evaluate? You will again check the X value and take the average. And let's assume that you are getting a new C1 value somewhere here and new C2 value somewhere here, right? This is C1, let's say new C1, and this is new C2. Now, again, you will do the same task. So, this task will be repeated until or unless you will not have a stable centroids. You will not have a stable value of C1 and C2. That is how this algorithm works internally, mathematically, right? In the upcoming video, I will try to demonstrate you the practical illustration of this idea, what I'm trying to convey here. As of now, I have shown you visually. So, the complete idea would be that first of all, take randomly the value of k. It will take, maybe for example, in this case, we have picked up the value of k as 2. Depending upon that, it will take random centroids in the given available points that we have. The second step is to calculate the distance of all the data points with respect to the centroid of C1 and C2. Whichever is closer, for that data point will become the part of that C1 or C2, wherever it is finding the closing sense, right? In that sense, we will be having a group of C1 clusters and C2 clusters. Third step is to evaluate the new value of C1 and C2 by taking the average of all the X and the Y axis that we have. We will get a new centroid and we will repeat this task again, means finding the distance of all data points and finding the near ones. Now, you can ask me until what point of time we will keep on repeating this task of finding near points and then finding the average. I would say whenever you will not get a stable value of C1 and C2, means whenever in your next iteration you have seen that the drastic change of C1 and C2 is not there. It's stagnant now. That is where you have to stop your algorithm. So this is how internally this k-means clustering algorithm works, and it will help us to find out the suitable clusters that we want, right? So this is how the things will work in the k-means clustering algorithm. Now, practically, you will get a better understanding of the same. So what I will do is in the upcoming session, I will show you the practical mathematical example plus implementation for the same, so that you will be able to get the better understanding for the same. So now I hope that you got a clear picture of how the k-means clustering algorithm works, what's the mathematical intuition behind the same. What I will do is in the upcoming session, I will show you the practical demonstration for the same so that you will be able to understand implementation wise also how the things are working, and whatever things we have learned so far mathematically will make sense to you practically as well, right? Anyhow, in the as I told you in the last part of the module, we will cover up end-to-end project with a different data set of marketing campaign, but still here I'll take open source data with the help of which I'll try to demonstrate you these three techniques and their implementation, and at the end I will showcase you end-to-end pipeline as well. So this is how the complete flow will go. So stay tuned. I'll see you all very soon in the upcoming videos. Bye bye everyone, and see